Okay, on the word problems, it says the number of customers in a grocery store is modeled by this function, and you have an equation where y is the number of customers in the store and x is the number of hours after 7 a.m. At what time is the maximum number of customers in the store, and how many customers are in the store at that time? So if this is going to be modeled by a quadratic equation, the most people that are in the store at the time is the vertex. So that's the maximum value of a quadratic. So we're looking to find the vertex, and this one's in standard form. If it's in standard form, we have to find negative b over 2a, which is negative 10 over 2 times negative 1. That is negative 10 over negative 2, which is positive 5. Okay, so what that means is it's 5 hours after the store opened, and the store opened at 7. So the vertex, the axis of symmetry, is at 5. So the most people are there at noon because 5 added to 7 is 12, and that would be 12 noon. Then they ask how many customers are in the store at that time. So we're going to have to plug 5 back in, and that's negative 5 squared plus 10 times 5 plus 50. And so y equals negative 25 plus 50 plus 50 equals 75. So there are 75 people in the store at noon. Okay, number 23. The height of a bridge is given by this equation. Y equals negative 3x squared plus x, where y is the height of the bridge in miles and x is the number of miles from the base of the bridge. How far from the base of the bridge does the maximum height occur, and what is the maximum height of the bridge? Well, to me, this one would be easier to solve if it were in the intercept form, and so I'm going to put it in intercept form. So you have 3x squared plus x, and an x factors out, and you're left with 3x plus 1. And so that's intercept form. Your intercepts are at 0 and negative 1/3. And that, remember, this is miles. So 1/3 of a mile is still a pretty good distance. That's pretty decent stretch. Okay. So half of that, half of 1/3, you know what? This is over a negative, and so that's going to make that positive. Half of 1/3 is 1/6. So your axis of symmetry is 1/6 of a mile. Okay, but they said, how far from the base of the bridge does the maximum occur? And that would be 1/6 of a mile. Let's put there. Now it says, what is the maximum height of the bridge? So from there, you're going to plug it in. You have negative 3 times 1/6, and that's going to be squared, plus 1/6. So whereas we don't like fractions, these aren't really hard. This is negative 3 over times 1 over 36 plus 1/6, and that's negative 3 over 36. And I'm going to put 36 in the bottom here because we have to have a common denominator in order to combine them. 1/6, if I change 6 to 36, I have to change 1 to 6. And when we combine these, you have 3 over 36, which reduces to 1/12 of a mile. Which doesn't sound like much, but this is the height. So that's how tall the bridge is 1/12 of the mile. And so that's it. Good luck on your test tomorrow.